It's another math day here with teacher Jenny. Now, please join me for this second part of the video on sampling distribution. I made another video because I made a mistake somewhere on the second combination on the problem, especially on the sample mean. Now, I would like to say thank you to Jisoo Kim because through Jisoo Kim, I really had an awareness that I really made a huge mistake in there. So sorry on that one. Anyways, I'm just a person, so I can also make a mistake. But I would really gladly would love to hear from you. You can send me a comment there or suggestion, any suggestion or anything that you wanted me to know. Feel free to leave a comment. I'll be reading that out and replying to every comment. Sorry for Jisoo Kim, I did not reply your comment there because our internet connection went out thanks to the provider. Very good. So I was not able to um, reply to you, but I am showing really my gratitude towards you in this video. Thank you very much. And that is why I'm going to redo. I'm going to record another one. And this is again with the same example. So this is now on sampling distribution with the given set of data, 123, 126, 129, and 132, and also 135. So now let's say if I wanted to have four sample size. Okay, as a researcher, I have to say for that one. So let me say I'm going to have four sample size. So how many outcomes am I going to have? So again, we can solve out our possible outcomes by making use of the formula NCR. This is the combination formula in which this is equal to n factorial over n minus r factorial times r factorial. Now, in my discussion, I changed this part, the variable that we are using. Instead of us using our n there and c and r, I am replacing this one with the capital N and the small letter n. Now, why? Because you might be confused later on with the n in there because the NCR, the n there is referring to the population size. But our n in statistics, we are referring to that one, the small letter n, we're referring to that one as the sample size. So that might lead to confusion. So let us just have this one for our formula. So we have n Cn or n taken n. So meaning to say we will be finding for how many possible combinations are we making out from that population, and we are to arrange the numbers according to the sample size. So we have this formula as n factorial and then n minus n factorial times n factorial. So plugging in our n here is the number of values found on your given. We have 1, 2, 3, 4, 5. So this is now 5 taken. Sample size, as I've mentioned, it's gonna be 4. So this is now 5 factorial over 5 minus 4 factorial times n factorial. Now our n, sorry, this should be 4 factorial. Okay, now in if you have there a calculator, so kindly locate this function, the NCR, on your calculator. You may go ahead and press that one and you will know the total possible combination for this problem by pressing in 5 and then the function NCR on the calculator and then the number 4, and then you will obtain there the possible combinations. But if you don't have, then you might have to go through with the manual computation. So in manual computation, all you have to do is to express the factorial in terms of multiplication. So this is how we interpret factorial. We multiply in a decreasing order. So we will be multiplying 5, 4, 3, 2, 1. So that is how we interpret factorial. So we have here 5 times 4 times 3 times 2 times 1 over 5 minus 4, that's 1 factorial, over 4, times 4 factorial. Next, since we have factorial on the denominator, let me just change my 4 times 3 times 2 times 1 into a factorial so that I can um, cancel out something so that it will be easier for me to solve. So again, we can have it as 4 factorial here. That is for the 4 times 3 times 2 times 1. That is similar to 4 factorial. So we can cancel the 4 factorial on the at the top and at the bottom. So that is now with 5 over 1, or simply your 5. So this is now our number of combinations for that given values. Now, the first step in getting the sampling or constructing the sampling distribution is for us to know the population mean. Why do we need to go through and finding for the population mean? Because in population mean, we would have an idea on what we are expecting as the sample mean for every combination of our samples in there. Because more likely your population mean might be located somewhere in the middle. I'm not saying it's gonna be at the middle really, or your center of the values. No, it's not gonna be. Although it can be, but that's not always the case. Now let's try to find out that one later. Let's find our population mean. By the way, population mean, this is also known as parameter. Take note, your parameter discussion. Parameter is a measurement or a descriptive measurement which describes your population. So this is population mean, and this is a parameter. Okay, now getting your population mean, we have now the symbol as the mu there. That's your population mean. We are simply adding up your values in there and dividing it to how many population, or what will be the population size. Or simply to say it, I'm just getting now the average. So we have 123 plus 126 plus 129 plus 132 plus 135. We divide this one with how many numbers are there. We've got that one as 5. And our mean would be equal to, let me just add it up. Okay, we have 129, 132, 135. We divide that one with 5, and that is equal to 129. Okay, so I hope you really are to solve this out on your own and try to check whether I really have a correct value for that one. Because without you doing your part in practice, you will not really absorb everything if you are just watching the video. So I might as well recommend that you need to solve it out and go through with everything on the video. Next, we have there our population mean as 129. Let's now move on to our finding the, or listing down the different combinations for our sample. So again, we have 1, 2, 3, 123, 126, 129, 132, and 135 as our data. So all you have to do is to combine those values and make a combination of 4 numbers, because our sample size is 4. So we must have 4 numbers in one combination. And we start with the first 4 values there. We have 123, 126, 129, and 132. So that's your first combination. Now, in writing for the combination, all you have to do is to change the last part, the last number there, until you reach the last number on the given, which is 135. And once you reach that one, that is automatically telling you that you will be changing the number before the last number there. So let's try to do that one. So again, we have the first combination is 123, 126, 129, and 132. Next combination is we will be changing the last part or last number. So we copy 123, 126, 129, and then change the 132 to the number which is next to it, and that is 135. Okay, now we have now 135 on the last number there. That means to say we're changing one number here. And that number will be the third number. So changing that out, we have now 123, 126. So from 129, we change this number to the next number on the given, which is 132. And next number is 135. Notice we have 135, and again, this is our guide in which this will help us know when to change our numbers. Next, we'll be changing. Now, supposedly, we're changing our third number, and the third number there after 132 is 135. So if you say 123 and 126 and then 135, you cannot have any other number right after that one. So you cannot form a four number on one combination. So that is a no-no. And instead, you will have to change the second number now. So changing the second number, we have 123. From 126 here, we go to the next number, which is 129. And then we have 132 and then 135. Again, we have 135. So we change a number. So supposedly, we are to change the third number here. That's the pattern. But since third number is 132 and the next number to it is 135, you cannot create a four number combination. So that means we change our second number. But again, if you change your second number, if you try to look at this, 123, we're changing 129 to the next number, which is 132. The next number to it is 135. We only have three numbers as in one combination there. So that's a no-no. So that means when we wanted to write the next combination, we are now changing our first number. So instead of 123, we'll be using this next number, which is 126, and then copying the next values to it. We have 129, 132, 135. So that's it. Now, if you try to check, this is 5 combinations. We have 1, 2, 3, 4, 5. So that's 5 combinations. Now, if you wanted to really practice more on how to list down the combination, I've made a video on listing down the combination. Try to find it on the details below. You can find the link to the listing of the combinations for 15 possible combinations. So try to check that video also. Now, next, we are now moving on to finding its sample mean. So we're simply adding this out. So we have 123 plus 126 plus 129 plus 132. We divide this out with 4 because we have 4 numbers on the sample size. And again, we are just getting the average for this one. So that's the sample mean. And please take note of the symbol for the sample mean. That's X bar. So this is equal to 127.5. And this is now what I made a mistake on. I guess I made a copy paste on my value, which is found at the top on the first combination. I'm so sorry on that one. So we have 123 plus 126 plus 129 plus 135 divided by 4. That will be equal to 128.25. And thank you, Jesso Kim. Next, we have 123 plus 126 plus 132 plus 135. We divide this one with our 4. This is equal to 129. Next, we have 123 plus 129 plus 132 plus 135. We divide this out with 4, and this is equal to 129.75. Next, we have 126 plus 129 plus 132 plus 135. We divide this out with our 4. This will be equal to 130.5. Okay, so there you go with your sample mean. So we're now moving to writing or constructing our sampling distribution. And again, this is pretty similar to your discrete probability distribution because we're having our x there, but this time our x is the sample mean, the x bar, the sample mean, and we will have our probability for each of the sample mean. So we're here, we are listing down those sample mean already with this one. We are arranging that one from the smallest sample mean to your highest sample mean. So again, we are going to write or construct our sampling distribution. We write 127.5 and then 128.25. Now, sometimes when you're doing the sampling or finding the sample mean, it's not always the case that you will be arranging or you are given the arranged value of your sample mean. So try to check out some examples on your book as well if you have those. You can check out some examples in which there are really examples that are not written like this one. It's really arranged. There are really sample means that are not arranged accordingly. So I hope you can find that one. So again, going back, so we're now on the probability part. So we're now checking how many 127.5 are there on our sample mean. So we only have one for each of the sample mean, by the way. The sample mean there is unique. So all you have to do is to have it as 1 over 5. 1 over 5 because we have 5 combinations. So that's 1 out of 5 combination. And that is equal to, in decimal, we have that one as 0.2. And again, this is 1/5 and also this one. And in decimal, we have 0.2 for that one. Okay, so you can check it out if you've got there the correct probability because that would sum up to 1. So we have 0.2 plus 0.2, that's 0.4, plus 0.2, that will be 0.6, plus 0.2, that will be 0.8, and 0.2, that will be 1.0. So we are now on the right track. So let's now move on to drawing our histogram. Now, if your teacher doesn't require you to draw your histogram, then that's okay. That's really fine. But if your teacher is requiring you to draw your histogram, then you might as well draw it. So this might be our 0.2, and we have our sample mean on the horizontal axis. We have 127.5, we have 128.25, and then we have 129, and then 129.75, and 130.5. This is our sample mean. While on the vertical axis, we can have that one as our P of X bar, or that's the probability of your sample mean. So you can draw, if you have this same probability all throughout your sample mean, you can have that one as a straight bar. That's gonna be with this one, so I can have it divided there. Let's try to make our life easier. So that's it. That's your histogram. Okay? So I hope you are now ready for your upcoming major exam. Good luck, everybody, and please try to stay tuned for another video coming from me. And again, in math, really, the secret is hard work and a lot of practice. So this is your teacher Jenny again saying good luck and have a nice day.